Alright, so this is our Honors Chemistry Section 3.1 lesson video part 2. So hopefully you've already watched part 1 where you learn the rules of significant figures, and so now we're going to actually use them in calculations. So hopefully it'll kind of come together for you a little bit more. So in general, a calculated answer cannot be more precise than the least precise measurement from which it was calculated. When a calculation has multiple steps, you must check significant figures after each step. So we're going to talk about how you do significant figures for addition and subtraction versus how you do it for multiplication and division. So for addition and subtraction, when adding or subtracting, your answer can only have the same amount of decimal places as the number with the least amount of decimal places. All right, so y'all, again, we already talked about this in the previous video. You can't do a calculation, like let's say that you measured 27 meters in 13 seconds. Like say you were doing some sort of time measurement, a speed or something like that. Let me grab my calculator real quick. Okay, so if you look, both of my answers only have, my numbers that I've measured only have two significant figures. But if you put this into a calculator, you're going to get this right here. 2.076923077. So you can't report this answer as assuming that you have measured out all of these decimal places. So that's what significant figures in calculations help us do. So what I'm going to teach you today is I'm not going to teach you a new way of rounding. We're going to follow the same rule as you already know for rounding. And that is 5 and up rounds up and less than 5 rounds down or stays the same depending on how you learned it. I'm just going to teach you how you know where to round. Like, do I need to round at the decimal and just get a whole number? Do I need to round after one decimal place? That's what I'm going to teach you for significant figures, is where do you round, not how to round. The rules of rounding are the same. So let's look at some adding and subtracting examples. Alright, so it says calculate the sum of the three measurements, give the answer to the correct amount of significant figures. So when you type this into your calculator, you're going to get 369.76. And then of course meters plus meters plus meters is meters. So when we're adding and subtracting, we look at the amount of decimal places. So this number has 2 decimal places. This number only has 1 decimal place, and this number has 2 decimal places. So we want the same amount of decimal places as the lowest number. So this number only had 1 decimal place, so that means my answer can only have 1 decimal place. So that's where I need to round. I need to round after the 7. So like I said, y'all, I'm only showing you where to round. You already know how to round. A 6 is going to round the 7 up. So the answer you should report is 369.8 meters. So see, you have 1 decimal place just like our number with the least amount, and you did your normal rounding. I'm just showing you how you know you're supposed to round after the 7, because otherwise the question's not going to tell you where to round. Alright, so let's look at a couple more. And so this is just my answer. So feel free to pause it and try these if you want to. I'll assume you've done that already. So in our top question up here, we're adding these 3 numbers. So when you add these 3 numbers, you're going to get 79.15 meters. And don't be forgetting those units. I'm super picky about that. So how do we know where to round? Well, my first number has 1 decimal place. My second number has 2 decimal places. My third number has 1 decimal place. So my lowest amount, of course, is 1 decimal place. So that means I need 1 decimal place in my answer. So I'm going to round right here, my line's almost on my 1, right here after the 1. So, you know rules of rounding, 5 and up rounds up, so the 1 becomes a 2, so it's 79.2 meters, and that is my answer. So again, you're just using the significant figures to figure out where in the number you need to round. All Alright, so I'm going to assume you've tried this one. Notice you're subtracting this time, but you still follow the same rules. So when you put this in the calculator, when you subtract, you are going to get 17.31 meters. Alright, so again, we look at our decimal places. This number has 2, this number has 1. So our lowest amount is 1. And just to let y'all know, sorry, that was just a total coincidence that all 3 of them had the lowest number as 1. In reality, your lowest number could have been 2, it could have been 3, it could have been 0 decimal places. So just know I accidentally just happened to pick 3 where it's all 1. So I want 1 decimal place again, so I'm going to round right here. So in this case, a 1 does not round a 3 up, so I get 17.3 meters. Okay, and so please don't think you found some shortcut that is always 1 decimal place. That's just the 3 that I pulled out of the book, just all happen to be 1s. Probably should check on that before I just pick randomly out of the book. Alright, so let's move on to what happens when you multiply and divide. So when you're adding and subtracting, you're counting the lowest amount of decimal places. That's the easier one for everybody. It's the multiplying and dividing that's a little trickier. Okay, and so there's my answers. Alright, so when you multiply and divide, your answers can only have the same amount of significant figures as the number with the lowest amount of significant figures. So see, this is why you had to learn the rules from the first video. So we're not looking at decimal places anymore. We're looking at significant figures. And so what's hard is for y'all to switch over. Even though I told you we're looking at significant figures now, a bunch of y'all, you keep reverting back to decimal places. So decimal places for adding and subtracting, significant figures for multiplying and dividing. All right, so let's look at one together. So it says the width, length, and height of a small box are 15.5 centimeters, 27.3 centimeters, and 5.4 centimeters respectively. Calculate the volume of the box using the correct number of significant figures. Okay, so we all know volume is length times width times height. So we need to multiply our 3 numbers. So we have 15.5 centimeters times 27.3 centimeters times 5.4 centimeters. So when you put that in the calculator, it's going to give you 2,285.01. Now this is centimeters times centimeters times centimeters, so this is centimeters cubed. Okay, super picky about that, so make sure you got that. So now we need to figure out where to round. So remember y'all, we are not looking at decimal places, we are looking at significant figures. So 15.5, none of these are zeros, they are all significant. So this number has 3 significant figures. 27.3, these are all significant because none of them are zeros, so it also has 3 significant figures. 5.4, again, they gave us some easy numbers to work with. No zeros, they are all significant, so there are 2 significant figures. So the least amount of significant figures I have is 2. That means my answer should have 2. Now this is where some of y'all struggle, because then you'll count out 2 decimal places. Remember, decimal places only applies to adding and subtracting. We need 2 significant figures, not 2 decimal places. So when you're counting significant figures, you're going to start at the front or left of the number. All right, so is this 2 significant? Yes, it is. Is this 2 significant? Yes, it is. I mean, neither of them are zeros. Zeros are the only questionable ones. So there's my 2 significant figures, which means I need to round right here. So we all know an 8 is going to round the 2 up, but what are you going to end with? Unfortunately, a lot of people give me this as an answer. Well, y'all, that doesn't make any sense. When you're rounding, it's like an estimation. It makes no sense for me to say, oh, 2,285.40, that's about 23. That makes no sense. Any places that you cut off that are to the left of the decimal, you need to put in zeros as placeholders. So I'm going to put in 2 zeros as my placeholders because remember, zeros after the significant figures, if you can't see the decimal, so notice I did not put a decimal point, are not significant. So see, these two are significant, these two are not. They're placeholders. So it does make sense to say, oh, 2,285.01, that's about 2,300. That makes sense. Another way you can do it is you could put it in scientific notation. You could say, oh, okay, well, it's going to be 2, 3. So I'm going to put my decimal right there. So 1, 2, 3, it will be times 10 to the 3 centimeters cubed. And so again, you can see you have your 2 decimal places if you don't like plugging in the zeros. Either one works, okay? So this one was kind of tricky because once you have to start filling in zeros, people start getting a little confused. They're not all that tricky though. Okay, so let's look at a couple more. All right, there's my answer. All right, so you can try the top one, or you can just wait for me to do it and then try the bottom one, but just make sure you try one at some point. All right, so it says solve each problem and report with the correct amount of significant figures. So when you type the first one in the calculator, you will get, flip my page here, 1.47. And meters times meters is meters squared. So again, we got to figure out where to round. Do I want all 3 numbers? Do I want to cut off the decimal? Do I want to just cut off one number? Where do I need to round? Well, remember, we're multiplying, so we're counting significant figures. So the 2 and the 1 are significant because, of course, they're not zeros. This back 0 is significant because I can see the decimal. So this number has 3 significant figures. This number, the 7, is significant because it's not a 0. This front 0 is not significant. This back 0 is significant because I can see the decimal. So this one has 2. So that means my answer needs 2 significant figures, not 2 decimal places. So I'm going to start at the front of the number. The 1 is significant because it's not a 0. The 4 is significant because it's not a 0. So there's my 2 significant figures. So now I need to stop and round. Okay, so again, y'all, I'm not showing you new rules for rounding. I'm just trying to show you where to round. So 7 rounds the 4 up, so it becomes 1.5 meters squared. Just like that. All right. So again, pause it and try the bottom one if you haven't already, and then we'll look at it together. So it says it takes 10.5 seconds for a sprinter to run 100 meters. Calculate the average speed of the sprinter in meters per second and express the result to the correct number of significant figures. Okay, so first of all, y'all, hopefully you already know speed is distance over time. If you didn't, though, they give you the hint of meters per second. That means my meters should be on top, my seconds should be on bottom. I'm dividing. Okay, so I'm going to do 100.00 meters divided by 10.5 seconds. Okay, and see, this 0.00 actually becomes important when you're looking at significant figures. All right, so when you plug this into the calculator, it's going to give you, a super long number, 9.523809524. And then because the meters in a second don't cancel, it's meters per second. So we got to figure out where to round, so we're counting significant figures. All right, so we know the 1 is significant because it is not a 0. All of these zeros are back zeros. Remember, it's not based on where the decimal is. Back zeros mean after or to the right of the significant figure, which is a 1. So since I can see the decimal, they are all significant. So this number has 5 significant figures. On the bottom, 10.5. The 1 and the 5 are significant because they're not zeros. This 0 is significant because it's a middle 0. Don't forget about those middle zeros. We hadn't had one of those in a while. So we have 5 and we have 3. So our lowest amount is 3. So remember, y'all, we want 3 significant figures in our answer, not 3 decimal places. So the 9 is significant, the 5 is significant, the 2 is significant. There are my 3 significant figures. So that's where I'm going to stop and round. So is a 3 going to round a 2 up? Nope. So my answer becomes 9.52 meters per second. And that's it. Super easy. Just take some practice. All right? So let's move on. Hopefully you at least tried one and got try to write at some point. Otherwise, there'll be some in the section assessment, so you can always try it there. So there's my answers. So next one, it says, a gas at 25 degrees Celsius fills a container whose volume is 1.05 times 10 to the 3 centimeters cubed. The container plus the gas have a mass of 837.6 grams. The container, when emptied of all gas, has a mass of 836.2 grams. What is the density of the gas at 25 degrees Celsius with the correct number of significant figures? All right, so we haven't technically covered density yet. We'll cover it in section 3.4, but density is mass over volume. So that means I need the mass and I need the volume. So if you look, it tells us the volume right here. It's 1.05 times 10 to the 3 centimeters cubed, but it gives me two masses. It gives me the mass of the container and the gas right here, and then it gives me the mass of just the container right here. So how do I get the mass of just the gas? I just subtract. I take the container plus the gas, and I subtract just the container. Okay, so the mass of my gas is 837.6 grams minus 836.2 grams. So when you subtract that in your calculator, you are going to get 1.4 grams. Now, this is a multiple step problem, so we need to stop and check our significant figures before we then divide. So here I subtracted. So remember, when you're adding and subtracting, you're counting decimal places. So here I have one decimal place. Here I have one decimal place. So that means I want one decimal place in my answer. And look at that, we have one decimal place in our answer. So this answer is fine the way it is. If I needed to alter it, I would round and then plug it in down here. Okay, a rule of thumb also is when you are carrying significant figures to the next step, sometimes you add an extra, like go to your significant and carry one extra one over, but this one's perfect just the way it is. All right, so my mass is 1.4 grams, and my volume is 1.05 times 10 to the 3 centimeters cubed. So this time I'm dividing. So when I divide, the answer my calculator gives me is a super long one. It's this right here. Oh, it's just a whole bunch of threes, so 3 repeating. And then notice my unit will be grams per centimeter cubed. All right, so now I need to figure out where to round. Well, this time I was dividing, so I'm going to look at significant figures, not decimal places. So 1 and 4 are both significant, so this top number has 2. And then remember, for scientific notation, disregard the 10 and the power. So 1 and 5 are significant because they're not zeros, and this 0 is in the middle, so it is also significant. So it has 3 significant figures. So remember, we want the lowest amount in our answer, so we want 2 significant figures, not 2 decimal places. All right, so these front zeros are not significant. But remember, y'all, it doesn't mean they go away and we don't write them. It just means I'm not going to stop and round just because they're there. So this is a front 0, it's not significant, I'm going to keep going. There's a front 0, not significant, keep going. Front 1, not significant, keep going. This one is significant because it's a 1. So there's 1 significant figure. I keep going. The 3 is also significant. So see, now we have 2 significant figures, so I'm going to stop and round here. Remember, just because the zeros aren't significant doesn't mean they go away. Like, I'm still going to write them in my answer. It just meant I didn't stop and round because of them. I waited until I got to the actual significant figures to stop and round. So my final answer would be 0.0013 grams per centimeter cubed. And so see, we have 2 significant figures in our answer. All right, so you just got to be careful. Significant figures are tough, but you got it. All right, so let's move on. That one was super tricky since it was a multiple step problem. All right, and so there's my answer. So then it says, to how many significant figures should the mass of the container be measured with and without the gas in the previous sample exercise for the density to be calculated to 3 significant figures. Okay, so in other words, what they're saying is on our previous question, we only needed 2 significant figures. What measurements would we have had to where we could have gotten 3? So if we go back, if you look, our original masses each had 4 significant figures. Okay, and so when we subtracted them, we got 1.4, which only had 2 significant figures, and that was what determined that our final answer would have 2. So if we wanted a 3rd significant figure, we needed another decimal place here, which would have put us at 5 significant figures each. So each of my masses would have needed 5 significant figures. So our answer to that is we would need 5 significant figures on those masses. Because remember, they had 4, but it only gave us 2. So to get that 3rd one, we would need another significant figure. All right, so let's knock out this section assessment. So if you haven't been trying any of these, make sure you pause and try some of these. So how are accuracy and precision evaluated? Okay, because these are just verbal ones, I'm just going to answer. So accuracy, remember, is how close a measurement is to the true or actual value, whereas precision is how close multiple measurements are to each other. All right, so number 2, it says a technician experimentally determined the boiling point of octane to be 124.1 degrees Celsius. So that's my experimental. The actual boiling point of octane is 125.7 degrees Celsius. Calculate the error and the percent error. Okay, so I'm going to pull this down here, although it's number 2. All right, so remember, error is experimental minus actual, or E minus A. So I would just plug in. So my experimental is 124.1 degrees Celsius. My actual is 125.7 degrees Celsius. And so when I subtract, I end up getting, oh, where am I? There we are, negative 1.6 degrees Celsius. So that is the error of the technician. But it also says calculate percent error. So percent error is the absolute value of E minus A over A times 100. So let's plug that in real quick. So my E is the 124.1 minus my A, which is 125.7, absolute value of that, over A, which is 125.7, times 100. So remember, absolute value is going to make my answer automatically positive. So once I do that, I end up getting 1.27. And remember, the unit for percent error is the percent sign. All right? So, again, if you haven't tried any significant figures ones, pause this and try it first. So, 11 soccer players. Where are you going to measure or count soccer players? You're going to count, so A would have an infinite amount of significant figures. So remember, you cannot underline for that. You have to put the infinity sign or write infinity so I know what you're talking about. All right, part B, we got some front zeros, some middle zeros, and a back zero. So remember, 7 and 2 are significant because they're not zeros. Front zeros are never significant. Middle zeros are always significant, and back zeros are significant if I can see the decimal. And so remember, y'all, back zero means behind or to the right of the significant figures. It's not in relation to the decimal. All right, so part C, we know the 1 and 8 are significant because they're both not 0. This 0 is significant because it's a middle zero. These are back zeros. They are only significant if I can see the decimal point, which in this case I cannot, so they are not significant. All right, and then last one, part D. 5 is significant because it's not a 0. These back zeros are significant because I can see the decimal. So all 3 digits would be significant in that place, in that one. All right, so let's erase and move on because we're almost done with this section. All right, so it says solve each of the following and express your answer with the correct number of significant figures. All right, so in your calculator, when you type in part A, you are going to get 1.296. All right, since I'm multiplying, I'm counting significant figures, not decimal places. So all these front zeros are not significant. The 7 and the 2 are. So I have 2 significant figures in this number. Here, the 1 and 8 are significant because they're, of course, not zeros. These back zeros are not significant because I cannot see the decimal. So since both of them have 2, that means I need 2 significant figures in my answer. Remember, 2 significant figures, not 2 decimals. So the 1 is significant because it's not a 0. The 2 is significant because it's not a 0. So I need to stop and round right there. So the 9 is going to round the 2 up, so it just becomes 1.3. No units on these. All right, so part B, we are subtracting. So when you put that in the calculator, you are going to get 0.865. Remember, for adding and subtracting, you are looking at the number of decimal places, not significant figures. So this number has 3 decimal places. This number has 3 decimal places. That means I want 3 in my answer. Well, look at that. My answer has 3 decimal places, so I don't have to round at all. Okay, sometimes you don't have to round, and that's okay. All right, so let's look at our bottom one. So we are multiplying here. When you put this in the calculator, it's going to give you 1.89 times 10 to the 14. Okay, your calculator might not give you that. It just depends on whether yours does scientific notation or gives you a whole bunch of zeros. But this is what I get when I put mine in. All right, so remember, we're multiplying, so we're looking for number of significant figures. So the 5 and 4 are significant because they're not zeros. These back zeros are not because I can't see the decimal point. The 3 and 5 are significant because they're not zeros. But all these zeros are just placeholders. They're not significant because I can't see the decimal point. So both of them have 2, so that means my answer needs 2. And again, y'all, this was just a coincidence that both numbers have the same amount every time. That's not always going to happen. Obviously, you just saw previous examples where that was not the case. So I need 2 significant figures, not decimal places, in my answer. So the 1 is significant because it's not a 0. The 8 is significant because it's not a 0, which means I need to round right here. The 9 is going to round the 8 up, so it becomes 1.9 times 10 to the 14. Just like that. All right, so hopefully significant figures weren't too rough for you. Like I said, it just takes a lot of practice, and it just takes a lot of focus on when I'm adding and subtracting, I'm looking at decimal places. When I'm multiplying and dividing, I'm looking at significant figures.